Alrighty, welcome back to 105. So we've done all of the content for the course so we can have fun now. So the last topic we will touch on is files. So why am I doing this? Well, because this will help you write useful programs. So using files is not testable, however, it's mostly string input and it's nothing really that different than what you've done before. So previously we saw lots of different ways to get inputs from typing a command. Then we can access it in our main function. Today we'll see how to use files and create a program that uses them because, well, as you probably discovered during your labs, especially with some of the later ones, inputting a bunch of input every single time is kind of a pain. So we can use files and get all of our contents from files instead of typing it in the terminal. So you can open files and close them when you're done. There is an API. Remember, API, Application Programming Interface, are basically a bunch of functions you can use. And this is in the C standard library. So to open a file that you can use, there is this fopen function that takes two arguments. And we can see they're both const char pointer. So they both expect C strings. One is called a path name and the other is a mode. And then this function returns a pointer to a file. So path name is a string representing the file name I want to access. So the file name, maybe some directories ahead of it. Mode is a string representing what you want to use the file for. So you might, if you used Python before or any other languages, it essentially uses this as well. So if you want to open the file for reading, so you just want to get input from it instead of writing something to it, you can just use the string lowercase r. That means you're opening the file for reading, you're just getting data from it. And fopen returns a pointer to a file. You don't actually get to know what type that file gets represented at because, well, it will depend on what operating system you're using. And it will return a pointer to a file or null if it fails for whatever reason. And like with malloc that returns you a pointer, you have to close it. The operating system has to keep track of what files you have opened and things like that your program's using. So the nice thing to do is as soon as you're done using the file, you should close it, which means you are done using it. And to do that, you should use fclose, and it takes a single argument called stream, which is a pointer to the file, and that should be the pointer you got returned from fopen. Similarly, when you call free, it should be the pointer you got back from malloc or realloc or calloc or any of its friends. So you can use this getLine function that we looked at too for files, because getLine will allocate memory for you to go ahead and read the input into a C string that it will malloc and do all that stuff for you. So remember, it will take a char star star, so it will actually write a pointer value to you that's stored at this buffer. It will also update the size, so how big the allocation is, and then the file stream. Previously I said just make it standard in and it would work. Well, now we know other options we can do it. We can do it with any old file, it doesn't have to be standard in. And this returns always the number of characters written or the number of characters we read, excluding the null byte. So again, if we use this, this is the preferred way to read a string. So if I initialize the value with buffer p with null, then it'll just malloc for me. And if I want to reuse this over and over again, I can just give it its modified pointer and it will internally call realloc if it has to, and that string is valid until the next time I call getLine. So this matches the entire line, including the white space and the ending new line, and again it returns the number of characters written, excluding the null byte, and then that last argument can be from a file. So let's develop a grade calculator then. So people have probably always done this. You know, how many of you have done this where you're going into the final, you know the rest of your grades, and you're like, what do I need to get a 75 or something like that? Everyone's probably done that, right? How'd you do it before taking this course? Like spreadsheet or website or something like that? Google Sheets. Yeah, well, we can write a program to do that. So let's just do that for fun. So we're going to write a program that takes a file called grades.txt as input. Each line of the file is a grade on an assessment. We're going to expect 9 labs, 1 midterm grade, and then we'll calculate our current course grade using the weights for this course. Then we'll determine our minimum grade, maximum grade we can get based off the results of the final, and then figuring out, what final exam mark we need for some target grades. So let's get into that. So I've already written a little bit of boilerplate code. So just to get us started and save myself some typing, so we'll have main. First function we'll call is read grades. That should read all the grades from the file. Then we'll have our calculate course grade function, which should get our minimum, maximum, and get our targets that we want. So I've already written some of the read grades function, so we're going to use that fopen function. So it's going to do fopen, file name is grades.txt, modes is R, and if I look here in the current directory, I also have my grades here. That was just testing. Let's do something like that. So let's say these are all our grades. I'll just do them in order, lab 1 to lab 9, and my midterm grade at the end, which would be worth more points. So here, I'll fopen, make sure that the file I get is not null. If it is null, then I'll exit with an exit failure. Otherwise, I'm going to initialize everything I need for getLine. So I'll initialize my string pointer to null, the size to 0, the length to 0, and then I'll just have while 1 or while true, mean the same thing. I'll call getLine. I'll give it the address of my string to modify, malloc if it needs to, the address of size so it can modify the size value, and then the file I want to read from, which is just given by, or I named file because that's what I got back from fopen. And then this will tell me the number of characters I actually read, and I break out of this loop if length is less than or equal to 0. If it's equal to 0, it means I'm at the end of the file. If it's less than, it means there's an error or something. So all I'm going to do is free that string. It's going to get reused every single time, so it's going to get reused for every single line. And then I'll just do fclose. So if I go ahead and I just print off whatever the heck I read, actually that'll probably be a bad idea. So each time here, string represents my line. So in this, I just have my grades. They could be floating point if I want. Doesn't really matter. Let's assume they're floating point just to make the calculations easier. So every time through this loop, I could just create a variable called, this is the grade I got on that assignment, and I can use from my string functions, there's that A2F that takes a string, returns a double. So I can use A2F if I remember that. So this will take a string and return me a double. So just to make sure I read something from the file, let's just print off, hey, I read, and then whatever value I read, just to make sure that we're getting all of the values. So we can do something like, do something like that, compile it, run it. I can see that if I look up, oh, look, I read everything from the file, so now I can use it in my program. So some other things I want to store these grades in probably an array, right? Because I want to use them to go ahead and calculate my marks. So what would I do if I want to, where should I create an array if I want to use it? Let's say I want to use that array in my calculate course grades function. So this read grade should read all that grades in the file into the array, and hopefully my calculate course grades can actually use it. So how would I create my array, or what should I do here to actually store all those values I just read? Any suggestions whatsoever? Okay, I will make a suggestion then. So I probably want an array, at least to start off with, probably like an array of doubles from my lab grades. right? And oh, how many do I need? Well, I know, a double const int labs lab length, or labs length. So I know there's 9 labs. Maybe I just say lab grades, and I can go ahead and say labs length. Something like that. So I don't even have to initialize it because I want this read grades function to initialize it. So what I want to do is, well, it should initialize everything here, so I should probably give it 2 arguments, the lab grades and the lab's length. Probably something like that. So if I do that, I of course have to add the arguments to my function. So I'm now taking 2 arguments. My 2 arguments are, well, it was an array of doubles called labs grades. Again, they don't have to match. And then an int called labs length. So now I can go ahead, I can use both of these functions, or I can actually access this array in this function, go ahead and initialize it. So I probably want to keep track of what lab I am currently assigning to this array. So let's say I'll just create int I equals 0. And then here, every time I read a grade, I want to assign it to that lab. I assume they're actually in order in this file. So I'll just assign it to currently labs, lab grades at index I, and then equals grade. So I assign it, and then I can just do plus plus I. So everyone agree that should read all the grades, or at least all the lab grades? All right, seems good. Ish. All right, so that should read all of my lab grades. So, is that all I need? Okay, well, I probably want to read the midterm grade too, right? So, double midterm grade. So, if I want to read the midterm grade, can I just do something like this? Midterm grade, so I'll give it as an argument here. Then double midterm grade. And let's just say here we'll only do that if I is less than 9. So if it's the first nine grades, we'll go to lab grades. Otherwise, if I is equal to 9, which is the last grade in this file, we'll just say midterm grade equal to grade. Is this good? So I'll scroll down a little. Any arguments with that? I should get some pushback now, yeah. Yeah, I have to give it the pointer to this, right? Because this function will just get everything's passed by value in C. So it will get a copy of midterm grade, which right now is currently, if I start at main, start executing my program, right now, midterm grade's an uninitialized value. So if I use it here, I get a copy of an uninitialized value. It probably is complaining at me, yeah, it's uninitialized. And then here, I never read that uninitialized value, and I just assign this function's variable called midterm grade, which got initialized to some garbage, equal to whatever I read from the file. By the time this function returns, it's all gone. So if I want to actually go ahead and set it in a different function, then I have to go ahead and do something like this. And instead of just less than 9 here, I should probably use labs length, right? Make it more general. And then since I changed it to a pointer, of course I have to dereference it. And then in here, I have to do address of, like we do with scanf. So that should read all of my grades and everything, right? So that reads all of my grades. Let's go ahead and calculate my grades. So maybe I use all the same arguments. So here's my calculate course grade function. I will just copy all of the same arguments. So, So, if I want to calculate my course grade, given that I have lab grades, the lab length, and the midterm, how would I go about calculating my grade? Go through and take the weighted average. So yeah, I can calculate, let's create a variable called, I don't know, course grade. Initialize it as 0. So I would need to go through and... Yeah, all the labs are weighted differently. Ooh, how do we want to contend with that?
I mean, we could create like an array of like all the weights that just correspond to all the grades.
Okay, yeah, so we could go ahead, create an array of all the weights. So if you didn't hear that, we need to take a weighted average of everything, right? So we need to know, well, we have from the file what we got. We probably need to know what's out of too. And then we need to know how much it's worth towards our final grade because the labs are all weighted differently. So what we could do, these are lab grades. Well, we need the lab weights too. We probably need the lab, what they're out of, so the lab totals, I guess. That's everything to do with a lab. So does it seem like a smart idea to have 3 arrays that all need to have the same, sorry? They're out, technically they're out different amounts, right? Some are worth 10, or some are out of 10 marks, some are out of 12, some are out of whatever. And your exam, and the midterm's out of a different number of marks too, right? If we want, if these are just our raw grades, I guess we could input our grades as a % too, and then we only need the weight. But in this, I'm not. But if I do something like this, this kind of smells because I have to, you know, for this right lab, I have to make sure that, okay, if I'm calculating the grade for lab 1, I have to make sure I use the same index from all these arrays, which is kind of bad, right? Yeah? Yeah, maybe a struct. I just group them all together. So if I'm looking at this, I probably want to make a struct. Maybe I want to make a struct, I don't know. Let's just not give it a name yet. What does it need? Well, in this case, it would have a double for the grade, double for what it's out of. I'll just call it total. Again, this is how I'm thinking of doing it. You could just input the percentage that you got, and then we have a weight. So those are all the things that do with a weight. And this doesn't even translate to a lab, right? It's anything you're graded on. So it's, I would probably call it it's anything you're assessed on. So I would just probably call it assessment. And if we want to, you know, not type struct everywhere, we can do type def, struct assessment, we can just call it assessment T, something like that. Or if you're in C-land or some other thing, maybe you do capital A assessment, doesn't really matter. So let's go ahead and modify our code a little bit. So in here, well, here, okay, we still have labs, but now let's group them all into this assessment type. So we can just create an array of assessments called labs, and they are labs length. So, and now the names kind of make a bit more sense. So create an array of structs. We are of course allowed to do that. And then here, well, I should modify this function to take labs and then labs instead of labs grades because I'm trying to generalize it. So now I have to go through and fix all my types. So instead of an array of doubles, it is now an array of assessment, whoops, not that. It is an array of assessment types. Here is also an array of assessment types. And then here, okay, I have to modify it because now let's change the name. So we'll change the name from lab grades to just labs. And then we're only modifying labs.i.grade equals grade. So now we're just assigning that one grade field in this read grades function. So we probably want to initialize, the weights and what they're out of and all of that fun stuff. So actually, let's rename this. Well, we should also just treat the midterm as an assessment as well. So here, let's just go ahead, change the type of the midterm grade and just call it assessment T. We'll just call it midterm. And then similarly to the labs, we'll just use, we'll just give it a pointer to the midterm. So now this is an assessment. We'll call it midterm. Go up. This is also a midterm, and we'll call it, it will be an assessment T. And then, of course, we'll have to go through here, and we can do our fun arrow notation so that we have the midterm grade is equal to grade like that. So this should fix everything. If we go ahead, compile, everything should still compile. We might have a few warnings. So we got unused parameter, unused parameter, unused parameter. That is all fine for now. All right, we are now in good shape. So we've generalized it a little bit more. In our main program, we've initialized assessment. We've created an assessment for all the labs, an assessment for the midterm. And then this read grades function went ahead and read all the grades from our file into that. So that's pretty good so far. Should also probably take into account the final. And we should probably just initialize all the weights and all the totals in probably a different function just so we can, have some, have some more organization to our code. So ideally, what we would want is like some initialize assessments function probably, where we give it the labs length, address to the midterm, and then the address to the final. And the final, we're just going to assume that it's not total. There's no grade or total from it, but there's going to be some weight for it. So we're going to create this function called initialize assessments. So let's go up here. I'll just copy paste a bunch and then call it initialize assessments. Add on the final here. Oops. And then here, this function. And the totals for the labs. So, to initialize all of the totals for the labs, well, I can go ahead, just write a for loop. Thankfully, I didn't name it like lab, I didn't have one assessment for lab 1, lab 2, lab 3, lab 4, lab 5, everything like that. So, I can use a for loop. So for I equals 0, let's loop over all the labs. Whoops. Labs length plus plus I. And we can go ahead and say all their totals. Let's just assume for now they're all out of 10. I know some are out of 12, some are out of 7, some are out of 10. Let's just assume they're all out of 10 for the purpose of this. And they're all weighted kind of differently, right? So I want to assess their weights here. Anyone remember what the weights are? Yeah, 2, 2, 2. Yeah, 2, 2, 2. Like the first 3 are 2, then the next 3 are 3, then the next 3 are 5. So how would I write that out here? What's a smart way to do this? If I is less than 3, then the weight should be 2. Else if I is less than 7? then the weight is 3. And I assume otherwise, else. Ooh, we're getting some disagreement here. So, so the last 3 labs are worth 5. The middle ones are worth 3. Yeah, see, we're getting a bit uneasy here. So let's go through this and see what would get assigned. So first time through, everything's 0 indexed, right? So lab 1 would be index 0. So if I is 0, well, 0 is less than 3, so its weight is 2. That's good. If I is 1, well, that's the second lab. That's less than 3. It'll be 2. That's good. I is 2. That's the third lab. Its weight should be 2. I is equal to 3. That would be lab 4, right? Off by 1. So because we did an if, else if, so as soon as this is now false, so 3 is not less than 3, it's going to go into this branch. And remember, if we have a whole else if chain, only one line will happen at only one true will happen, even if multiple things are true. So it will go into here. The weight would be 3. That's good. So that's for our, what is that? That was for lab 4. So lab 6, that is index 5, right? Well, 5 is less than 7, so it'll go in here. Lab 6, that is index 5. That's good. That will also go in there. What about lab 7? Lab 7 is index 6, right? In this code, lab 7 would get assigned a weight of 3, which is wrong, right? So what's my fix? Less than 6, right? So less than 6. So that should get all my weights. Anyone disagree with that? All right, and then finally, let's just say the midterm weight was 30, right? And then the final weight is 40. And then let's just say the midterm, we don't know what the final's out of. Let's just say the midterm was out of 75 points for whatever reason. I forget. What was your midterm actually out of? 75? Was it 75? Okay, so we're already good. 75. So do that, compile it. All right, so that should be everything initialized. So all the weights and totals, as long as it's not the final, are initialized here, right? So everything should be all hunky-dory. So now we can actually start doing this calculate course grade function. So calculate course grade, we want also the address of the final. So we need the final as well. So we'll just do assessment T, final. All right, so now we can calculate our course grade. So to calculate our course grade, it's like a weighted average of everything, right? So we could go ahead and just go through all of our labs again. So for I equals 0, I is less than lab's length, plus plus I. Well, our course grade is just going to be plus equal that labs, and we can see why we used a struct. Well, it's just what we got on that lab divided by what it was out of, so that gives us some range 0 to 1, right? As a percentage, so we don't need to multiply it by 100 or anything like that. And then it's that whole thing multiplied by the weight of the lab, so I'll just do something like that. So everyone agree with that? All right, so if I wanted to add my midterm into the mix, well, it would be the midterm weight, and then the midterm. But if I do that and I change 3 variables, it kind of irks me a little bit. Like, sure, it's just this line, but if I wanted to generalize my program a bit more, maybe I could just create a function that gives me the course, or the course grade component for an assessment. So I can just say assessment, and then I can generalize it a little bit. So it doesn't matter what I'm doing. Instead of just saying this for the labs and the midterm, I'll just generalize it for an assessment. So I'll just return, in this case, I'll just replace labs with assessment. Whoops. Yes, labs with assessment. And then instead, I can feel a little bit better. I also screwed this up a little bit. Whoops. So I can do the course grade component. And then here, it's actually labs I, and then I give it the address of that. Before, I was doing it wrong, and it would have been the first lab every single time, which would have actually been wrong. So I can do something like that and write it in a function, and then here I can do course grade component again for the midterm, nice and easy. I don't like, you should just write a function for stuff. You shouldn't kind of replicate stuff. So this is what we got so far. So now we can print off current course grade. Let's see what we got. We can do LF. Let's just do it to 1 decimal point. And we can print off our course grade so far. So compile. Just a warning that we're not using the final. Yeah, that's fine. So let's see what we're at now. So there's all of my targets. So our current course grade is not a number. What did I screw up? Dereference? Shouldn't need to.
Oh, because you're not actually.
Sorry?
Because course grade, you need to, because you're not returning it at the end of the calculate course grade function.
Calculate course grade?
Yeah.
Yeah, it's not returning it, but we're just printing it here. Yeah. Shouldn't have to do with anything passed by value. So here, we can even see print, let's say, we just go ahead, let's just print our assessment grade, assessment weight. Let's make sure we did it correctly. And then our assessment total, make sure that we did it correctly. Oops. So if we get through here, looks like we did it correctly. Looks like everything was fine. Got all of our weights. Everything like that looks good. Huh? Oh, we have weights. Oh yeah, we have weights as 0. That's not good. So yeah, we were dividing by 0. So how did we do that? Oh, here, we screwed up. We just did labs weight. Again, I screwed up. I didn't use the array bound. So it's just labs I dot weight. Labs I. And that is the fun with pointer, that fun, stupid pointer crap. So again, it treated that as just the first element every single time, and it's just reassigning the first element over and over again. So if I'm using the array, well, of course, I should use it as an array. So compile, run it. There we go, that's better. So our current course grade is a 47 based off these grades. So what did we get? You know, did all right on a few labs. We bungled some of them real bad. So our course grade got affected quite a bit. So now is the fun part. So that is our course grade without the final, right? Yeah. Yeah, this is assuming we got 0 on the final. So this is, well, yeah, that's if we just did nothing with the final. So yeah, maybe we just name the variable course grade without final, just to make ourselves feel better. Just to make sure. So, yes, that is our current that's our current grade without, well, we can remove this print. So that's our current course grade without the final. All right, that looks ugly. What about if I wanted to print a percentage there as well? So, can I just do something like this and it'll work? Yeah, I have to escape it, and with format specifiers, I just have to escape it with another one, right? So if I do percent, that will give me the percentage. So now if I compile, run it again, I can see that, yeah, 47%. And that's, if I get, that's like the worst thing I can do in this course. So if I have a 47%, I don't quite pass, so I still have to show up to the final. So maybe I just printf minimum course grade. Well, that's just what I do if I don't show up to the final at all. Point F. So that's my course grade without final. And then my maximum course grade, if I get 100 on the final, that's just my course grade without final plus whatever the weight of the final is, right? So compile, run that. I can see, okay, that makes sense. It's just that plus 40 in this case because I don't have any other weird adjustments. Then maybe I want this course grade to be like the actual percentage I have in the course. So the weight, double course weight without final is equal to 100 minus the final weight. So maybe to feel better about this, I can do, you know, times the weight. So that will give me the course weight without the final, or yeah, that'll give me the weight without the final. And then, you know, that's what I got without it. So do this. I probably need, whoops, that's not right. Whoops, so it's just divided. Course grade, course weight, yeah. Course grade without final. Times, it's 100 times that, right? So 100 times my course grade without a final divided by the weight. So yeah, currently I have like a 78, not including the course, which should mean if I get a 78 on the final, I still have a 75 or 78 on the course, right? So now let's go through all of our fun targets. So here's all of our targets. So let's figure out the grade I need to get on the final to get a 50. So wait, do you have this saying here, 5-0 and go? No, that was a Queen's thing. All right, we're better than Queens. The Queen's saying was 5-0 and go. I think the saying here is C's get degrees. So that is a 60. And then we can shoot a little higher. We can get a B, 75, or an 80, or an 85. So here, I just created an array for all my targets. I can use that array length macro and then have this array of all my targets. So I can figure out what actual grade I need to get on the final to get my target grade. So this is slightly tricky. I need to think about a few cases here. So how should I write this? What are some cases to get? For instance, right now, is it possible for me to get a 90 in the course? No. Is it possible for me to get a 45 in the course? Right? So I have some cases I need to consider. So some cases I need to consider if my target grade is, well, if my target grade, so if this target grade, so it's just targets of I, is currently greater than, my course grade without final plus the weight of the final, then, well, I can say this is impossible. So do this, run this. Currently, nothing is currently impossible. But if I do something, let's say we increase it to, 95, just to test it, we should see that our 95 target is now impossible. So good, that works. And the other case is else if targets I is actually less than or equal to our course grade that we already have without the final, we can go ahead and just printf, stay home and chill. Although probably not recommended. Again, in this course, or with this grades, I can't stay home and chill, but let's go ahead and say I wanted to just fail the course for whatever reason. I could do that, test it. If I want 45, I'm good already. I can stay home, chill out, not do anything. So the fun case is with the other case. So what would I need if I fall in between those targets? Anyone help me out with this little quick calculation? So the target, probably minus my course percentage so far, right? So this is essentially the weighted average I need to get. Like the weighted course grade is just the target minus, whoops, not equal, minus the course grade without the final, right? That's what I need to get with my weight. So that is the final percentage I need. Double. So if I want to figure out what grade on the final I actually need, well, it's the same as the calculation I need before. So I could say I need a 1 decimal place, please, on the final. And then in this case, similarly to before, it's just 100 to bring it to a percent. The final percentage I actually need divided by the weight of the final. So if I do that, this should be my whole program. If I compile and run that, hey, it seems to work. So here, I actually want to pretty it up a little bit, do a percent, compile, run it again. So we can see now that, hey, if I need a 75, now, I just need to just get a 70 on the final. If I want an 80, I need an 82. If I need, if I want 85, I just need a 95. And then, hey, this is simpler than before, after we've written the program, of course. If I want any other grade, I can just throw the grade in my targets, and then I know what I need to sanity check it. Let's just say, what my course grade before was like a 78.3, just to make sure I did all the calculations correct. If that is my target, it means I should, to maintain it, I just have to get the same grade on the final, right? So if I run that, I can see, okay, minus the rounding error. Yeah, it's just because of the rounding. So minus the rounding display issue, I need to get a 78.3 on the final or whatever. So that is our useful program of the day. You could extend this as much as you want. So you could make it so that, you could put a negative grade to indicate the grade or the final mark gets, or the lab weight gets shifted to the final or something like that. You could you could modify the code too, that this is like grade you got and then comma total. You could modify the file to do whatever you want, but this is just to give you an idea of an actual useful program you can write. Every program you write or every program you use probably uses files in some type of way. So this is just another step. We didn't learn anything that new. It's just another example of things you can actually do now with just C, and well, the file API just has an open and a close. Aside from that, it is nothing new. So that is our last content lecture. We'll be doing a review in the next lecture, and remember, Monday is off for us, and we'll do a review closer, or I'll do a review stream closer to your actual exam. So with that, remember, pulling for you.